is our advanced concepts workshop. And we wanted to do this to create an opportunity for folks to get a sense of how we see these tools being used beyond their kind of non-standard usage. We provide a lot of templates, and we have our workshops, even our deep dives kind of really are trying to explore like what is like kind of an ideal workflow for these tools, right? But we are always aware of the fact that the tools are set up in such a way, because it's Grasshopper and it's parametric, that there's so many things you could do with these tools, right? They're not just the standard usage is great, but it's just the beginning in a way. So maybe hit the next slide there, Ben. So we talk a lot about how with conventional design processes, we have this difficulty in going from a simple drawing to a CAD drawing to a 3D maybe, and then maybe renderings, and if you ever have to change it, you've got to kind of start over. And the parametric design allows you to kind of have this fluid workflow. And the next slide, which allows us to have a series of inputs, simple geometries, parameters, things like that, flowing that into a parametric workflow that can provide visualization, analysis, documentation, and evaluation sometimes at any given point in your iterative process, right? So as you're shifting things around, you're kind of always seeing what the design is in 3D often. Or at least, it obviously depends on how you're setting things up, but it allows you that sort of adjustment. And that principle can apply to even sort of non-standard usages that we're kind of looking at today. And so it's one of the other reasons I bring this up. So rather than having an analog drawing kind of that goes into a process that's a one-way street, we see this as a way of kind of exploring so many different ideas. And we actually have a really incredible example of this today, this sort of generative design example that sort of shows how you can sort of have certain kinds of randomness participating in the design process in order to sort of generate all sorts of ideas. Okay, so this is sort of where things change a little bit. The standard workflow, and this is very abstracted. Okay, so a standard workflow might have an input in a series of components and processes that process the data in a certain way, and then an output, right? Or a series of outputs. You may have a series of inputs, a series of outputs. You may have a series of different components as well. But the standard workflow is typically a certain series of components in a particular order. And there's ways of kind of expanding on that a little bit. Like in this sort of non-standard workflow, for example, you can see how B repeats. And if we maybe go to the next slide. So we have, when we start to vary the process, we have some things that we see. One is duplication, and these are kind of, principles of digital design, basically like that you've got duplication. The ability to duplicate a process can be used in a number of ways, and we're gonna look at that in a few instances. One where you might have a whole process that's duplicated. In the case of the agroforestry example, we have a process where we're designing modules with Plant Kit, and then we're using Plant Kit to design where modules go, right? So there's kind of like two layers of placing things. There's also the idea of using other processes, like sometimes we use Paving Kit to set up patterns for a pattern-based planting. And then other times we're just writing some custom thing that extends the process internally, or in the next slide, sometimes it's at the very end of a very standard process. And we'll show an example of that with our Boulder wall that we've written ourselves, that is hopefully at some point going to be integrated into Topo Kit, but right now is just kind of like a prototype. Are there any questions at that point about kind of what I mean by sort of non-standard? It's really fuzzy, I have to say, because even our standard approach to land kit or standard approaches have a lot of variation within them. But I think what we're talking about is fundamentally changing or expanding or duplicating processes that have kind of really qualitative changes to the overall ability to design and kind of take things to the next level.
Chris, just a quick question. Is there any component of LandKit or any part of it that is kind of like an open source, that it's kind of like editable?
No, not exactly. But there are ways of using the Python portion of it. Like there are ways of tapping into it, almost sort of like, well, you have the ability to kind of examine objects like a topo object or a plant object. You can do that if you plug that into a Python component. There's sort of non-standard things you can do. We're not going to talk about any of those particular examples today, but that's something if you're curious about, doing something unique and you need some direction on how to go there. We'd be happy to kind of look at that with you. Or maybe there might also be a little bit of time today to examine that, actually. So
awesome. Yeah.
I'm going to be able to squeeze that in today. This first example of architectural topography, really, it's basically topography, but the way that we're sort of stacking topography together in multiple layers is suddenly turns it into architecture, right? Because you've got floors and ceilings, and you're dealing with a lot more than just your standard kind of singular membrane, right? We're kind of dealing with multiple things. We got this idea when we were doing, we had a basic plan, and then we were adding in boardwalks and bridges and stuff. And we were like, why don't we just have like another layer of topography that kind of helps describe these, that just ties into the topography, which was kind of a fun idea. And then we thought, gosh, like, you could really expand this out quite a bit. And the reason you can expand it out is because of the simplicity of the setup, right? And it's one of the nice things about LandKit, and that you're not building all this custom stuff, and you have this big unwieldy script that you're then like taking and like duplicating and making it kind of do all these crazy things in multiple ways. You actually have something where you can have a fairly svelte, fairly simple script that describes a topographic layer, and then you can kind of deploy that at multiple levels. Let's look at the next example. The next example is agroforestry. And so where in the Topo Kit one, it's really just duplicating a topographic workflow and like, how do you integrate that? With the agroforestry, we're kind of, instead of doing in parallel, we're doing kind of in series. So we're taking a plant kit workflow to design a module or a series of modules where you could look at conditions within that particular module. And then we think about how we can deploy modules and think of placing modules as if they were plants within a landscape, within a bigger landscape. So if there's a big wet area or a big clay area, you might be growing something different. Or if you're doing just some sort of crop rotation, which is, kind of, I'm not sure if that's still within the realm of agroforestry, but exactly. But, Thomas could probably tell us that the ability to place these modules and kind of redesign the module independently kind of is a nice way of deploying an idea across a much larger landscape that's, reproducible, harvestable. You might figure out that you can drive equipment through something that is in a grid, or so there's other concerns with an agroforestry design that you don't have in a typical like urban landscape design, for example. And we have one other, so these were the three examples we kind of advertised: the agroforestry, the architectural topography, and then we also have this example we're going to talk about, which is generative tools. We have a generative script that shows how we can use Paving Kit and Topo Kit along with a bunch of randomized inputs that allow you to kind of generate a bunch of options. It's a very example-y kind of example. It's not a really it's not specific to a project right now. We built this example in I built it one afternoon. It was like, this is crazy. We have to show this to people. And this is part of why we made this workshop was that example. So I think that will be a fascinating way to understand how, some methods for how you can create randomization, but then also sort of apply things based on conditional sort of options, right? So for example, that mound pattern that you see appearing is always appearing in the largest portion of landscape, beyond the paths, which is a very simple conditional. But you could, if you can set that up, and you can say, okay, well, it's always going to appear in the first, three, whatever, the largest things, and then the other smaller pieces are going to get this other sort of treatment. It's an interesting way to kind of set up rules similar to the way we set up rules for, say, plant kit, where we have conditions, and we could have a bunch of different results, but the rules are going to still always be there and sort of be followed, right? And at least in large part. So let's go to the next slide. I wanted to include just a couple more examples that I thought were really interesting. This is a project I worked on when I was at Olin. This is pre-Paving Kit, pre-whatever. Paving Kit really doesn't do anything like this anyways. This is all like using Voronoi. But I think it's a great example of how you can set up a whole series of rules in order to generate a pattern that has a very particular look and feel, but is really truly organic, right? It has rules relating to how planting kind of these sort of planting rifts and cracks kind of join together. But then there's a real, you could input any exterior shape to this in order to get a different design, basically. And I think there were some other inputs like different attractors and things for where these, where the plantings would occur. All right, so the next example. This is another project that I worked on. This is a green roof project in California, in Cupertino, California. The architect is Raphael Vignoli. Olin was the landscape architect, and it's called, it was called Valco Town Center, but I don't know. I think that the name has changed a couple times. Ben, what's the next slide look like? Yeah, okay, this is great. So we created a whole series of tools for this in order to speed up different parts of the process. So there's kind of, some principles of Topo Kit in here, and some principles of, in that project of, things that very early ideas about how to place plants and things like that, this is actually interesting as a non-standard example because it's a number of scripts, and it's not just one script that does everything, right? And so it's a whole process. It's a whole, the team worked, they had a whole set of tools for building paths and doing certain things with paths, and then there was a whole series of tools for breaking up the site and rationalizing the site into this grid. And then there was a whole series of tools for, creating the topography, not a whole series, but it was sort of a tool that took all these inputs and created a topographic surface that represented the minimum surface you would need for soil volumes and things like that. And then one that translated and figured out where you would want your foam. And so there was all these steps, but it allowed for the designer to work within those steps, right, in between. So the designers still have a lot of control over how things look. Once something gets generated, they can still make changes and adjust and sort of tweak from a design perspective, but they're still being helped out quite a bit by the tools, and there's still quite a bit of automation. And the team that I was working with was able to generate, a bunch of Revit documents from, an updated design in about a week versus say probably a month or prior to this, we'd never really even described the landscape to this level where we had the thickness and we had the foam and we had all of these different things happening at once. Yeah, so that's another example I really like to share and talk about because I'm very proud of. So what's the next one? Oh, it looks like I got a few of those. This is one that's Ben's going to show a couple examples that are not necessarily ones where we're gonna do the demo, partly because we are making some changes to LandKit that might actually solve some of these things for folks, and so it seems silly to sort of share a script that then we're gonna solve for you in a few short weeks or months. So this is essentially using Paving Kit on a surface, right, on a wall rather than on a plane, which was a nice usage. And Ben's gonna talk through sort of the basic workflow of that and share that. But we use this as a tool for helping an artist with a proposal of his. What's our next slide? Okay, yeah, and then this was we had some folks that they do a lot of stacked stone walls, and we thought, gosh, well, why don't we just build a quick tool that can just give you're just giving an input of one of our walls. So this is a great example of extending beyond the Topo Kit workflow, the standard workflow, and just be able to plug in the wall and get, boom, a whole stacked stone wall from that. You can change the parameters. This is another one we'd really like to turn into a tool in LandKit, but we just like to share sort of the overall approach to this. The real examples where you're going to participate and get involved are the architectural topography, the generative design, and the agroforestry example. So those ones, we've got example files. We're gonna, that's gonna be much more interactive. But let me see the next slide. Yeah, so here's our timeline. I've done my intro presentation, and we're probably a little behind. Ben has a few quick examples, like I mentioned, the paving on the wall, the Boulder wall, maybe one or two others. And then there's an exercise that we'll do before the end of part one, where you guys will get to really kind of open up Rhino and Grasshopper and see this example and really mess around with it a little bit, and then be able to work on that and ask some questions, and we can talk about sort of moving beyond even this example. And then we're going to take a break. So because we're oddly enough, we're all in basically the same time zone, I think, and we'll be able to get lunch. What a concept. And then once we're all kind of refreshed, we're going to come back and we're going to do two more really interactive things, which is the generative design example and then the agroforestry example. We want to really provide a lot of time for you guys to really dig into these and really ask a lot of questions, and also provide a lot of time for Ben to really kind of walk through all the details of how the script is set up.
So generally, I hope everyone got the package, participant package. If not, we can drop a link into the chat. So let me know if you didn't get that. You really only need the participant package here at the beginning before the break for the architectural topography section, so that you can kind of open it and feel around a little bit. But also, we wanted to say, Chris and I will kind of be I'll be presenting mostly overall, and Chris will be he might throw in a question or two to sort of broaden the ideas conceptually, because we want this to be nitty gritty, but also talking broadly conceptually about what this means for design too. So if at any point, if you have questions, don't feel like you need to necessarily wait for the working in question section. Feel free to like ask them as you want to, unless you kind of want to see if it sort of like solves itself as you're going. So yeah, we just want to make that known. This can be, a little bit more informal and relaxed and forum-esque, so that you can really get an idea of what's going on as we're going through it, rather than feeling like you're waiting until a moment to ask a question, then we're jumping back between a bunch of different scripts and stuff, and we can really stay on what's going on. So yeah, so we'll jump into it. And again, like a lot of these quick examples I'm going to show at first are really not just speaking to, like what we've done, but also sort of what computational design is sort of thought of in general today as sort of this thing that, you use a line to create a fence or a bench or something like that. And, obviously that's something that we do as well, that a lot of people do and use these parametric tools for. So, you have these simple examples of having here's a fun example of just using a curve and then a topography and then packaging a set of tools and components in sort of a cluster here that allows us to create a specific type of bench, and using that and deploying it across the whole site with lots of different curves so that you can really just adjust your curves very quickly. And I think this is like very generally how we think about using parametric tools and computational design today, which, sort of in our ideas and theories don't encompass what is possible, if that makes sense. So yeah, we wanted to show this and just show like, with some simple inputs and a simple script at a very quick speed, you can deploy something very custom across an entire site very quickly. And again, you all are probably all very aware of that, and there are probably lots of people who are very aware of that. But this is something that I think will stay within sort of the realm of computational design forever, and it's useful. But to remain in this space is very limiting and very underplaying the possibility of a computer. There's so much more you can do with it, and I think that'll become a lot more apparent once we get into like the generative tool as well. But outside of packaging, we've used it for things that, when you talk about software like Revit, where you have things that you can deploy into a wall that is, this idea of BIM design, where you have something that is standard in the world of architecture, landscape architecture, that applies across the entire United States or the entirety of a country based on standards that you have, like, for instance, truncated domes for crosswalks. You can create a tool that will generate these for you according to the appropriate standards of how one is actually created, and then deploy it across an entire site with multiple different locations all simultaneously in a way that looks visually exactly how a truncated dome is supposed to look. So you have these ways of taking, very similar again to the benches, not just something very custom, but something that's very standardized, and using it as a package tool to deploy across a project or a site that you're working on. And it becomes an easy way to create something that's visually accurate very quickly and efficiently for a client or a project in general. But I kind of wanted to get quickly to the fun stack stone wall and boulder wall script that Chris mentioned before. Again, taking something that's an extension of a workflow, which, we have the workflow of Topo Kit that has walls and features within them that at the end of it, they come out as just a simple Brep that is ready to be just visually changed or applied a material to, or used as a placeholder for construction documentation to show, like, here's the wall where it's located, or a plan drawing. But that for visual purposes or documentation purposes, you can take it a step further and talk about using, a series of specific inputs for the type of walls or materials that you're using here at the beginning. And you begin with a simple Brep shape here. It's just a simple, rectangular form, and changing that into something that's a lot more complicated and a lot more accurate to what is going to be represented on the site itself. And so I'll jump into the script here a little bit in just a second, but I just wanted to show that, you know, these things don't have to be, when we typically look at a Grasshopper script, you see this like zoomed out image of this really complicated thing. And it's like, oh my gosh, this is super intimidating. But, you know, Grasshopper has been set up in a way that makes it easy to sort of create this package of components that allow you to very quickly deploy them in a lot of different ways that are very useful and efficient, that just create a single component here. And you can, and you know, this is generally how people create a lot of custom components as well, as these packages then become the actual component itself. But we have this sort of boulder wall version, and then Chris made this is the sort of stacked stone wall version, where it's, again, very similar. I think it's structurally built the same as the boulder wall, but then sort of smushed together to create the sort of flatter stone stacked effect. And if we jump into this, it might take a second because it's going to choke up a little bit here, since I had all these preloaded.
Yeah, it's a very, I'm just step in here for a second, Ben.
Yeah,
it's a very slow script, which was one of the reasons we haven't not integrated it into LandKit yet. It was just sort of like something we can apply at the very end for certain projects that we really need this for, like a rendering or something. But and it also, this is using multiple other plugins, right? So how many of you are not familiar with what a cluster is? Because we're right now, where you can see that box right there, we're sort of inside a cluster. The cluster, it allows you to select a bunch of functionality, and you can right click and then turn it, you know, the cluster icon is this box, right? It's that box right there. So if you select a bunch of stuff, it allows you to make this cluster. And this is one of the ways that if we haven't written a Python script, or we don't have a, you know, a LandKit component for something, this is a way that we'll begin to prototype the idea of like a packaged functionality for a tool. But it can also be a great way just for anybody who's building a project with a bunch of custom components to, you know, set up basically a tool. And the cool thing about this is if you duplicate within the other script, which is the main, you know, the sort of the parent script, and you can just do Control Tab Ben to get to the other script. No, within Grasshopper. Yeah, there you go. If we were to duplicate that cluster, all the functionality inside is sort of linked by default. So if you have like 12 of these doing different stuff across your whole script, and you decide, oh, wait, we need to add this other kind of level of functionality to it, or other level of detail, you can change the one cluster and they'll all update, which is also can be an extra tricky thing. But I just wanted to speak to that because the cluster is something I wasn't sure, Ben, if you were going to dive into that or not.
No, I wasn't going to, but I'm glad that you did, because I think that, you know, a lot of people kind of overlook that when you start jumping into sort of the Grasshopper realm. It's a very useful thing to keep in mind when you're building like big extensive scripts and you're trying to show people what's going on. It's easy to sort of break them down into clusters so that you can jump in and out and say, like, this is a chunk of functionality that's doing this. And I think that's something that that people who code, do a lot of coding kind of understand, but a lot of people who are coming sort of into the parametric or computational world from a background in design don't understand. That's super helpful to keep in mind and know about. So, you know, obviously Grasshopper makes it very accessible for people to use coding concepts very quickly and efficiently in the design and 3D modeling world. But oftentimes things like this are overlooked that make their lives and process a lot easier and more efficient, that, again, coders just inherently understand. But yeah, I mean, this is such a fun tool to sort of dig down into and look at and see that, you know, we're taking the wall that the input of the Brep here that we have, that's just the actual shape of the wall. In order to create the sort of stacked wall effect, we're taking the wall itself and then, you know, extending it higher and longer and below in order to be able to create the Voronoi pattern, which can then be smushed down in to create sort of the stack stone effect that we're looking at the tail end of the script. And I'll sort of jump through this a little bit, and you can kind of see that, you know, we're scaling them back a little bit so that we have a little bit of a cushion in between the different stones and the Voronoi pattern. And then oftentimes when we're working, we convert things into meshes once we're done making adjustments to the Breps themselves, so that we increase the speed and efficiency a little bit, since Grasshopper and 3D modeling software tend to process meshes a lot faster than they process Breps, since they're a lot more of a simple geometry to deal with typically. But we're also using, you know, we often use a range of different plugins because everyone has a little bit of something that they're doing that adds a lot to the process of building these scripts. And oftentimes there's no reason to reinvent the wheel. There's a whole wealth of community of Grasshopper and users and coders and 3D modelers that are creating these amazing tools and plugins that allow you to do things that you never thought you would know how to do, just because it never crossed your mind until you reach a moment where you need to do something like offset a mesh to create, you know, a volume of a flat mesh, and then you look around and someone's created that tool for you already. So, and oftentimes for free, there's an amazing community of people who just build a tool, provide it for free, and it's amazing. And they just have this whole other work life around that they just continue using these tools and allow us to use them as well. So, you know, there's a lot of mesh tools that we're using in this script that allow us to create volume to these forms that we're using, and then reducing them down in order to create the stack stone volumes that form together from that original Voronoi that we created.
Can we, you can open up the script, Ben. So this is a great example of a little bit of Python prototyping that we do. Hopefully that image, is that window showing up? You can just double click on the Python there.
Yeah, it's not showing up. I don't know if you locked it or not, or.
Huh, I shouldn't have.
Let me check and see if it's, oh, here it is. It was opening up underneath a window on the other side.
Okay, yeah. So basically, if you expand that a little bit, so, you know, the typical Python script, it allows this, you know, this is not part of our template or anything. I did this very quickly. I just created a brand new Python scripting component, and I imported, if you can zoom in on that control scroll, Ben. Yeah, so I'm just I'm importing a few libraries, the Rhino script syntax library, which is very commonly used. I don't even know if I'm using that. That's just often the first thing that's already in the script. But then I'm importing Rhino and the GH Python library, the parallel module. Part of the reason I did the parallel is because I was thinking about using it. I don't think I ever ended up applying it. So, but it's very simple here. We're just grabbing the mesh, you know, the mesh's vertices, and then it gives us a sort of a target number based on a percentage that we're giving. And then there's actually a function called reduce for the mesh, but that function doesn't exist within the Grasshopper set of, you know, standard Grasshopper components. And so that's one that we've written, or I've written this a few times, because it's one of those things where I'm like, I cannot remember which other script I used to do this, and it's a very simple task. So it's almost like just dropping a few Grasshopper scripts in. You're just writing a few lines of code, and boom. Sometimes it's not that easy. Very often it's not that easy. Trying to figure out what's going on, or what Grasshopper or Python want. So anyways, I just wanted to talk about that example briefly.
Yeah, and that also speaks to, like, again, talking about the idea of a cluster and sort of the workflow of developing your own custom tools and working into, you know, a workflow that you're trying to create for yourself or your firm or a class, for instance. The idea of using a cluster to combine a bunch of components together, but then once you start to learn a little bit more about coding, like Chris often does, we'll create a cluster of components that are performing a task, and then if you know the code well enough, you can know, like, okay, well, I can use Rhino and Grasshopper, Python in order to create something that's a much more simplified and streamlined version of this to sort of leap over 4 tasks and make them 1 task to increase efficiency and speed and make the cluster just a single component of these Python script editors and Grasshopper. And so once you get into this realm, you start to go from Grasshopper script to cluster to Python component. And then all of a sudden you have this component that works as a function that you can use across a lot of different projects or different tasks that you're doing. And so oftentimes we're jumping around and grabbing one of these, you know, Python script editors and just using it across multiple projects because it works a lot more efficiently than the 3 or 4 components that we would use in Grasshopper itself, even though we know how to use it that way. Again, the barrier of entry to Grasshopper is often processing and using a computer that is powerful enough to complete the tasks across a larger site or a larger project that you're trying to work within. And it's going to choke on me a little bit again. So this is again, like Chris mentioned, this is one of those scripts where we've built it out and we've created this functionality that we know works. And then now we want to incorporate this into something like Topo Kit. So looking at the principles of how it's being built will then be moved into the realm of an actual Python script in Grasshopper that becomes a tool that is much faster and more efficient than using the links of components together.
Yeah, a lot of the land kit stuff is often using parallel processing. It's using as much native stuff as possible. We don't really load any other libraries. Whereas here you can see we're using some of that, like the mesh offset. We're using some of those things. So if we were to use this, we would have to sort of build our own versions of some of these things. And so sometimes that can be a challenge to kind of integrating certain functionality. But yeah, so it's an interesting kind of way of developing things. So Ben, I don't know how much more you have on these shorter examples, but we are getting.
Yeah.
Okay, cool. We're getting pretty close.
I was just going to jump in. It seems like so we know, Thomas, you were at the Plant Kit workshop, so you have some more familiarity with Plant Kit, and I think a lot of the principles of Plant Kit, you know, translate over into Topo Kit, and we have some of the examples from our previous advanced workshops or our previous deep dives to sort of, just in case, Ushin, I don't know if you've spent a little bit of time using LandKit or not, but sort of knowing generally how it was developed and its original purpose of usage is helpful to understanding, you know, knowing the rules before you break them is a useful thing for when we're jumping into this, you know, architectural topography realm. But I just wanted to show briefly, like generally, like what, you know, the example of what we used Topo Kit, what it was originally designed to be able to do to, you know, sculpt topography and grading and creating walls and features and areas in order to create a fully functional and fully thought out landscape that you can adjust very quickly and efficiently. And so if you're familiar with this, I don't want to go too deep into it because, you know, for those who will be watching this video, there are other videos that you can watch to understand Land Kit and Plant Kit and Paving Kit to sort of understand how these work in the way that they were developed. But we're going to jump into sort of a way that we've kind of applied it to a new realm by looking at the architectural topography example. And and showing how you can use this in a way that's not just a single plane, but multiple planes stacked, multiple pieces of topography stacked on top of each other and interconnected in a way that allows you to construct buildings or, layers of boardwalks and things like that. So, if you're reaching this point in the video, if you're watching, maybe this might be a good time to go refresh yourself on how sort of LandKit works. And I'll say this for the PlantKit examples too, but we'll kind of just go right into it since we're getting into the weeds. So if you all want to go ahead and open up this example so that you are ready to sort of move things around if you want, and sort of pick at what's going on in the script and ask questions if you have them. But I'll start to sort of run through once. I'll give you like a minute or two here to open it up if you're not already ready to go, and then we can kind of jump in, and I'll talk sort of generally about where this idea came from. So as Chris mentioned, we started working on this project that had the boardwalks, and we had this idea of like we could just layer the topo, another set of topo on top of it and use that to create the boardwalks. But then it started thinking, it kept sort of lingering in the back of our minds until, as everyone knows, some of the news that came out about the line from the famous project, the line, the renderings that came out. They had the massive line there in Saudi Arabia, the idea of having this sort of vertical city that's built linear, like in a line that allows you to sort of create transportation and livability and access to nature and visibility, and sort of reduce the size and spread of a city down to a much more compacted, efficient space. And when we saw some of those renderings, we're like, oh my gosh, like you could create this using Topo Kit. Like a lot of the organic nature of the ramps going between the different levels made us think this reminds us a lot of our boardwalk example that we were working on. And so we thought it would be fun to sort of build an example of this for this workshop that was coming up. And it ended up being sort of its own thing that we really enjoyed working with and really want to incorporate into different projects moving forward, this idea of layered topography to create either buildings that look more organic or layers of boardwalks that will work pretty well, or even some of the examples that we see where it's like layered green roofs across different buildings and architecture that is filling a space for a project. We see the potential for Topo Kit to now sort of help architects potentially, or landscape architects that are trying to represent the architecture itself in their projects, which could be pretty useful looking forward for us and for many others. So just generally looking at the script, this is an example of what Chris was talking about, where we have that duplication of code here that represents the different floors. And so in this case, if you're doing like a 50-floor skyscraper, there will be duplicates of different floors that will be represented in the same way. So you don't necessarily have to have 50 different chunks of script in order to represent maybe a 50-story building if you're really going to jump into that realm. But you could copy, prototypical floors across multiple different levels, as long as you have an example that represents a single floor. But in this case, we're creating 4 different floors of sort of custom separate pieces of topography that we're working with. And, again, if you're familiar with sort of the workflows of Topo Kit that we have introduced before, I'm going to turn off some of the other stuff at the end so you can see sort of how it's constructed. And once again, if you're confused about, oh, go ahead, Chris.
Oh, sorry. Yeah, definitely. You can turn that stuff off. There's one concern, which when I open the script, there's a puffer fish component. 2 things. One, you can open it without the puffer fish. You can just ignore that, and there's a way to fix that, and we can show you that in a minute. Only because I only say that because puffer fish is like, it's a very no pun intended, bloated like set of scripts, and so it's like hundreds of components in a library, and it's if you're doing that kind of work, if you're like designing shoes and stuff, like it's a great script, but there may be another solution to do the offset mesh. The other thing, so that component right there, when you first open the script, it's going to basically say, hey, like you don't have pufferfish if you don't have pufferfish. And it's okay to sort of ignore it. What you'll get is a white component, and then you can just bypass it, like what Ben is doing right there. Yeah, so you can just bypass that script, and then you'll have a preview. But Ben's showing you something else right now anyways. So the one thing I would say, Ben, to turn on is the contours, just so that they can see the actual topography, because it's kind of hard with the meshes.
Yeah.
There we go.
So this way you can kind of see that we have, a range of different topographic elements embedded within each floor, mounds and depressions, ways to sort of add a little bit of interest. And then also, a bringing up of the middle of this lower floor on a ramp and I'll turn off this wall here so that you can kind of see what's happening on the inside. We're bringing up the middle element here to meet the ramp that leads up to the second floor. And so you have this sort of seamless integration of one floor to another through these different ramps, and then also integrating across that a series of staircases that allow you to transition across the different floors as well. So it sort of speaks to that sort of like new idea in architecture that you see in some of those renderings from like the line or other green roof layers that you're working with. And so we'll kind of jump into like what's happening at each floor, how we're building this, and how we're creating these different sort of seamless elements that come across, because typically when you're working with a mesh, it's the Delaunay mesh concept within Grasshopper is sort of creating a single surface of a mesh that's coming across. So sort of getting these fine lines and edges can be kind of difficult unless you're working with the idea of these projected areas that we're using here to sort of cut out different zones in the floors. So I'll turn this off really quick, and we'll go up to the beginning of the script. And again, if you have any questions about what's going on, or you're like, oh, you just have a comment to make conceptually, or asking like, oh, can we do this? Feel free to just stop me at any point and we can discuss it. So this can be a little bit more fluid. But the first thing we're doing here is we're just simply creating a piece of topography that represents the first floor. And so I'll turn this on. I was using the slope analysis here to sort of analyze the steepness of these different slopes and these ramps so that I can ensure that they're walkable going up to the middle of this first floor, so that it's easy to sort of make the second floor ramp accessible. But if I show the whole mesh here, you can see that it's encompassing the entire space. But the geometry that I'm using to construct it is sort of focused on the edges of where I want the floor to actually be represented. So I have these break lines that I'm using, and these are just a series of break lines that are representing the different parts of the topography that I'm constructing and forming here. And so it's not very much geometry here. It's just some break lines that kind of represent contours to create our mounds, sort of a bounding edge that represents sort of the raising and lowering of the overall floor itself on the outside edge. And then a few lines here that sort of help meet the staircase here at the bottom for this surface. So from that, what I'm doing is I'm taking that mesh and I'm using, I'll keep that there for a second, and I'm using a series of areas here. So I'll turn off all these others so that we're seeing just the first floor areas. So the areas here allow me to pick and choose the parts of the mesh that we're actually going to be visualizing and representing in different ways. So the boundary of my floor for the first floor then becomes the boundary of the different shapes that I'm using in my areas and project areas. And if I take this over to the second section of the script down here, you can see that, oh, I forgot to turn that off. You can see that now my areas are being projected down, and the parts of the mesh that we're not using for the floor then are not being used because it's not part of the areas that I'm projecting down. And so then I get my nice first floor topography being generated here using, and if I change anything, I can just shift things up and down as much as I want to to change the actual edge or the topography itself. And I'll do that once we kind of get closer to the end and we have all the different floors integrated, and I can kind of like shift them up and down together. So you can see things are sort of moving together and working together a little bit more efficiently. I believe one of our Instagram ads kind of showed a little bit of how that was working, but we'll play around with that too here in the example. So then the question becomes, sort of in this case, how do you create sort of that seamless transition from the first floor to the second floor? And the way that we achieve this is, again, we create this second floor in the same way. We've created a mesh that represents the second floor, but you'll see here where the mesh is kind of dropping off, we've created a series of walls that are, and I'll turn those on so you can see them a little bit better. We have these wall lines here that we've created that represent where we're trying to drop the topography down to create the ramp that's going to come up. And just like in the first floor example, we're using the areas to sort of pick and choose where we're actually going to represent the floor itself, so that what we have at the tail end is a representation of the second floor that excludes the sections of the mesh where the wall is actually being created to generate that jump from the ramp that connects to the first floor up to the actual level of the second floor. Go ahead.
Yeah.
Chris.
Yeah, so you may ask, like, well, why are we using a wall? And the one nice thing about walls within Topo Kit is they let you build very steep areas, right? So in this case, we needed a really, like, either we would have been building another level here with that light green, or we couldn't integrate it into that particular level. And the wall allowed us to make that like really extreme transition, right? In the sort of like topography that ultimately is just there as a way of projecting these areas, right? Like the areas are the ultimate, you know, they're where we're trying to get to. But the topography helps to guide that. And in this case, we just needed that really extreme drop off in order to get that ramp that's like, it basically feels like it was cut out and just folded like a piece of paper.
Yeah. So then you end up with this sort of like this single continuous surface here, this single continuous mesh plane here that allows us to create this sort of cutout drop off down to the next floor below, and that's being controlled by the walls. And so you can sort of adjust them and change them how you want to and make all kinds of changes and shifts to them. And you can see that we're also using, just like on the first floor, we're using these series of break lines to sort of define where our topography of our second floor is being created and generated in different locations. So, you know, we have a series of break lines creating mounds at different locations to add a little bit of interest. Again, sort of inspired by the idea of this line and like, you know, if this is the future of where we're going with cities, how can the sort of the technology that's being created today help make that possible? Not just tools that architects are using, but how can we sort of work together to think about architecture and landscape architecture, as I think the sort of the trend is going, as sort of one body of design that is working together in tandem. And so this sort of helps us see how even the landscape tools can become something that the architects can use as well, to sort of generate these more organic forms efficiently. And you'll see up here that we have you know, this layering of different, we have the sort of area that represents the ramp itself, so you can sort of distinguish that, and the area that represents the overall floor of the green space. But we're also using this tool, the collage tool, which you may or may not have seen in the land kit or Topo Kit workshops, that allow us to layer things on top of each other, so that if I want to change the direction of the path itself, I can shift just the layer on top, and it will change the location of the path, but then the green underneath of the overall floor remains the same and just fills in the space below, so that you don't have to adjust two surfaces. You just have to adjust one surface, and then everything integrates and changes for you.
It's live trimming the green, so it trims it. It smashes everything together and flattens it so that there's only ever one area. Like they're not really on top of each other. It actually breaks it out into different pieces, and you can also spit those out as a byproduct. You can see right there the component allows you to get surfaces and colors, so you can output those, but ultimately you can plug the area in and project that to a topography as well. So it provides some different options for speeding up those processes.
Yeah, and again, if you hadn't been a part of the sort of Topo Kit workshop, here's just like a quick example of how if I just shift the path area down below the green zone, the path area just kind of disappears. So because it sort of reads in the Z plane, whatever is the highest will be represented above the things below it, so that it kind of trims it out for you. So if I move this back above in the Z plane above the green zone, it will then trim out the green with the path area that we're using and add our path in to allow it, so that you can quickly sort of cut things and move things up and down. And this is something that I think that, again, if you go and watch the video of the deep dive for the Topo Kit, this is something that we talk about a little bit more in depth too. So another thing that, that's nice to do here is to make sure that, things are sort of meeting at a proper level. So we've created sort of a single line here to make sure that our staircase is sort of coming up and meeting this topography perfectly. So again, using those break lines we have lots of organic shapes, but if we have things that are not organic, making sure you have sort of linear elements that allow things to sort of seamlessly integrate one into the other. And in some cases, we have these sort of straight, simple rectangular surfaces, and in some cases we have something that looks a little bit more organic and flowy that the stair component will solve for you. So the idea of adding another floor, the third floor here, sort of follows the same principle. What we're doing is we're creating an overall mesh using the geometry that we're inputting here. We have the ramp that's being generated. It's kind of funny to look at here, but it looks like on the overall mesh, it's just a hole in the ground right there. And maybe I can turn on this one so that you can actually see it a little bit easier. You have this nice hole that's being generated in the mesh using the walls that's creating the ramp that goes down to the second floor. And then what we've done here is we're creating sort of a double level to the third floor here. And it's kind of just interpolating the mesh in between these two different levels of break lines that we've created. And then we're adding a staircase in between those. And then we've also pulled up this other ramp a little bit higher, just using the break lines, which is where this sort of more general gradual ramp meets the fourth floor. And so if we go over here and look at what that looks like in relation to the areas, we can turn this on and also turn on our third areas. And I think the mesh kind of makes it difficult to see. But you can see we have this sort of steeper ramp that's coming down, and this more gradual ramp that's leading up to the fourth floor. I'll try to stop here a little bit so you can see a little bit better. And then above that, up here, we have, again, our sort of overall orange planes that represent sort of the general floor itself, and then our paths that are over top of them. So if I move this one down, it will maintain the path over here on this sort of second tier of the third floor, but it removes it for this one since we moved it below the orange section here. So again, allows you to sort of change one and not the other. We sort of added this element that integrates into the staircase here, and I'll go ahead and turn on the stairs so you can see that we're using the stairs in organic ways as well to generate these sort of funky looking steps. The stair component's really fun to use because regardless of the shape of your surface, it will just sort of generate your stairs out of that and create odd and interesting shapes of your staircases, like grand staircases going up to other floors or different levels. So it could be a pretty fun component to use, even if you start putting in a bunch of them, it can get heavy, but that's just sometimes the nature of dealing with larger sites or complicated elements here. So then the last level here is the fourth floor, and again, follows the same principles. We have this overall mesh here that's being generated that we're using a series of break lines to create. I lost an earbud, I apologize. And we're using the levels of the previous lines to bring down the level of the floor to meet this ramp coming up from the third floor, so that we have a sort of seamless ramp that goes from the third floor to the fourth floor. And then we've also created this like fun little sort of terrace environment over here that kind of drops down sort of in front of this, pull out from the third floor, so that you can kind of have this more lookout area that can be kind of interesting. So if I turn on the areas for this one, you can see that it's only generating the areas where we've defined the floor to be based on our areas above. And you can see that, you know, in a previous iteration, we had the actual topography coming out a little bit further. But since we didn't want to add that much extra floor to the space, all we did is we just trimmed back the areas, and it pulled that out of the, it removed that from the overall preview. And now we have the actual floor plane that we want itself. And I'll unpreview this so you can kind of see that a little bit more clearly. And this one's being generated only using a boundary line of the actual floor itself. So there's no other geometry being used to generate this floor except for the single break line in the boundary. And it's very easy to sort of adjust these up and down. So if I just grab these control points and shift them up, I have to refresh it because this one doesn't have. So in this case, we're refreshing the topography here that is coming into our geoset. And then you get a little bit of a raised piece here. And I'll turn back on the contour so it's a little bit easier to see. And if we want that to drop back down, we can just drop it back down by pulling this stuff, pulling the control points down of the lines and refreshing the actual geoset itself. And so, you know, in some examples, like in the example of the second floor here, what we've done is, in order to create something that's happening updated right away as you're changing things, this is sort of something that we talk about in the deep dive workshop too, about when you have a large landscaping or dealing with a lot of topography that you're adjusting, you want to make a lot of changes and then refresh it so you see the changes that you've made represented in the topography. But there are ways to make it update live as you're changing the geometry. And one of those ways to do it is to use the add to geoset component, which allows you to feed the geometry directly into a component. And then when you change it, it will automatically update without having to refresh. So for instance, on our second floor here, we have this geometry that's representing that's sort of guiding where the floor is taking place. But since we're feeding that geometry into the add to geoset instead of using the create geoset component, it is going to live update our geoset when we change the geometry. So if I shift these curves up, it will automatically update this, this geometry. The other cool thing about this too is that since each of the floors are separate, it's not going to update the other floor since no geometry is changing. So you can change one floor very quickly since it's one workflow per floor, and all your other floors stay the same. So it increases the speed a little bit by breaking out your floors into different chunks of code and different workflows for each floor. Go ahead, Chris.
Yeah, I was just going to re-explain the geoset thing really quick.
Yeah, that's probably a good idea.
So the basic idea of a geoset is that there's a bunch of geometry in our sort of ideal workflow. It's pulling all the geometry off of a layer. So in this case, it's pulling the geometry out of Topo second. So if you then show them that layer, Topo second, and then everything under second, the boundaries, the break lines, the contours, you draw everything on that layer and it just brings everything in automatically. The only hitch is that it requires the refresh button. It requires a refresh because the way we're, like Ben said, we look at that in a typical workflow is a lot of times you have to go in and you have to change all this stuff, right? Fix this break line, fix this thing here, fix that thing there. And you're making a lot of changes. and then hitting refresh, because sometimes it can be really processor intensive to like try to have it update every time you change one little thing. But if you have a simpler workflow and you want to have direct inputs in Grasshopper, you can use this custom, add to geoset component, which allows you to put geometries directly into a geoset. If you can also have a geoset as an input, but if you don't, it'll just create one for you, right? So, and the geoset then is what get used to create either a new piece of topography or a topo patch in some cases, which we're not really talking about. We're not talking much about mods today. We're doing some smoothing, it looks like, but there's a lot more about mods and how you can modify topography. In these cases, we're kind of, because these are like, floating topographies, like there's no existing topography, right? We're working directly from inputs of break lines and walls and things like that to completely design the topography. But there are ways of having an existing condition and patching in changes or modifying the existing in certain ways. But I just wanted to kind of mention that really quickly. The other thing is, I just want to make sure everybody understands, that each of these layers is referencing a different set of geometries, within the layer structure here in Rhino. Right? Does everybody kind of get that? That it's sort of pulling directly from geometries that are in Rhino by pulling it off of a layer, a specific layer. And the nice thing about that is we have way fewer kind of things within Grasshopper to manage. We're not setting up all these different references and things. We just have like a live feed to what's happening in Rhino, and you can kind of more intuitively manipulate geometries in Rhino. One last thing I want to mention, and this is actually a tweak to the script. Do you see all of these panels? And this is actually a great, I'm kind of glad you didn't have this, Ben, because it helps us to kind of teach somebody this. So these panels here, if you right click, there's a, maybe just, there's a Grasshopper panel, which is really cool. So I'm gonna clear that. So if we were to take this button, I don't know which layer this is, you may want to rename it real quick to refresh 2 or something, refresh layer 2. There we go. Yeah, that's nice. And then if you right click on that button, you can say publish to the remote panel. And the cool thing is now that button is available in Rhino, right? So what you may want to do if you have a lot of these things and you're refreshing them a lot, you may want to just put all of those into that panel, and then you don't have to zoom all the way across, Grasshopper all the time. It's actually a really great way to sort of create your own little interface really, really fast. Like you can put sliders in that space, buttons, even text panels to sort of get feedback on outputs. Like if you're, anyways, I'm diving down the rabbit hole now. So
no, but it's something that we've used a lot in the past that makes sort of again, speaking broadly about LandKit in general, these tools are really trying to bridge the gap between the world of computer science that can create massive custom things that are specific to a project, and the world of design that a lot of the things that we still do are very analog and very construct as you go once you have the general concept and idea. So how do you sort of bridge the two worlds together in a way that allows designers to use relatively custom tools or relatively computational, like allowing the computer to do a lot of the tasks for you in a way that's intuitive and efficient and easy. And as simple as it seems, being able to keep people out of Grasshopper sometimes is the way to make it accessible for designers. Because coming from a school that was very, and I think a lot of schools are like this too, and a lot of our education is like this, where you have a lot of exposure to computers and modeling and these cutting edge tools, but they're still very intimidating and they're still very difficult to get used to. And they're still something that you don't really want. You know, once you get out of school, you're just starting to do things and it's easy to just stick to the status quo. So how do you provide a way for people to use it that is intuitive enough and easy enough so that they want to start applying it to their actual workflows themselves? And oftentimes, you know, in my experience, and I think in a lot of our experience, getting people out of Grasshopper is the way to do it. How do you allow them to use the Grasshopper tools without actually being in Grasshopper? And something as simple as being able to publish your refresh buttons after having the workflow set up to the Rhino realm is a way to do that. And then all you have to do is hand a script that's set up to a designer, tell them to just put the geometry in these layers, and then they can start shifting things around up and down. And when they're ready to update it, they just hit their refresh floor 2 button, and it will integrate the parts of Grasshopper into it that you're trying to get them to change. And I clearly made that. I adjusted a control point that is not supposed to be adjusted properly, and it's creating some chatter here in the floor. But you know, I think that sort of creating workflows in the Grasshopper space by someone who understands it and then providing it as a tool set to be used by a designer inside of a firm or inside of a school or in a school or educational environment is a way to sort of get people familiar and start to bridge that gap between this computational world and the analog design world that we still kind of live within in general. Something that maybe it's a little less applicable to architects who are getting a lot more exposure to computers and using computational design tools. But for, you know, the field of landscape architecture, that's something that we're still sort of fighting and battling against. Is the pencil is a tool, the computer is a tool. Let's start to explore the different ways that we can use them in a way that's logical and easy and accessible. And so I think that's where LandKit was born out of. And ultimately, a lot of these ideas and tools are, again, trying to make it usable and accessible to the different types of designers that exist today. So I mean, feel free to like play around with this a little bit. One script that I jumped over top of that I wanted to show that we talked about in the presentation is the paving, the alternative use for paving kit to a brick wall versus like an actual paving on the floor. Oftentimes I like to think of paving kit as like pattern kit, because I think that the tool sets within paving kit are going to starting to sort of grow into something beyond just paving itself. I don't know if you want to talk about that a little bit, Chris, or not, but I'll pull that up so that we can.
I was just going to say, maybe we dwell on this for another 15 minutes and then go and then spend just a few minutes on the paving thing before lunch. I wanted to talk about a few of the things that, you know, that I think are kind of like byproducts and things to consider with this workflow. So, you know, we talked about different ways of getting geometries into the, so we have the geo set, right, which can pull from a layer. And we have the ability to directly reference geometries and create a geo set that could be used, you know, instead of that. So that's one thing, one idea. Another way to think of this, because these layers are being coordinated, right? You could have one geo set that's being added to that is like a coordination set of geometry. So you could have like 1.5 and 2.5 or something like that, where you're using that information to kind of help expand, right, as like the connection points. So you might have, you know, in the locations where the two floors meet, for example, if you want to make sure that there's like a break line that both floors are hitting exactly, you could have that one piece of geometry that's guiding that in that case, right? It's just like one way of thinking about that. I think the way Ben has this set up is beautifully elegant and simple, considering the complexity we're looking at here. One of the things that we're trying to do is show that the geometry, you can still have your kind of like geometries in Rhino. You don't have to build everything in Grasshopper. Like there's an awful lot of really custom stuff happening here in Rhino, really creative stuff, you know, very custom forms and things that are being drawn. So that's one thing I wanted to kind of mention was sort of that relationship between the geometry in Rhino and how it gets used for this workflow. And it's not just about the workflow, it's sort of about what the designer's doing, and it's symbiotic, it's cybernetic, you know, it's not just a digital workflow, it's a you know, connected workflow. One other thing that's more of like just a note, which is that the draw areas component, Ben, if you want to kind of zoom over to that, we are ultimately spitting out areas that are meshes. And so Ben, if you were to like create a deconstruct component and plug those into that, just to show people how many points we're talking about. You'll notice this is one of the slightly slower steps within the process. Deconstruct mesh. You can also, yeah, there you go.
Let's do that.
Just plug that guy in there. So yeah, we've got a lot of points. So if we zoom in, there's a lot of fidelity to that mesh. We could change the resolution of that mesh if we needed to. That's one thought. But the other thing that I think is interesting is that you can use surfaces as well to draw an area. It is a slower component. A lot of people like love surfaces. They want surfaces as an output. And so we gave it to them. But the problem with surfaces as areas is it's very difficult to describe, to project to that topography really, really closely with the surface, and to do it efficiently. So it's slower and it's less accurate, but you get a surface. And it's just, we have a few options for that. So if you plug the A into A, these two components are very similar. It's just that one gives you surfaces and one gives you meshes. And then so if we were to plug these surfaces into here now, you can sort of see that, is that right? Maybe hide that, or yeah, so you can see that those surfaces don't, oh yeah, we need to kill that as well. I'm not sure what's going on here. Oh, we need to plug in a Topo Mesh to project too.
Yeah.
Yeah. The two, they're almost identical, like the inputs and the outputs. It's just that it's like one is a surface. But there's a few options. One is that you can change the cell size, which is how detailed that surface is, but you can already see that it's a larger time frame. Like we're talking, instead of 1 second, we're talking about a 6-second processing time. And then if you look, if you zoom in on like the little details, you can see that like these surfaces aren't really matching exactly. You can change the surface type to see, I think the other option, it's if you give it a plug in a 0 or something like that. There's a few options for surface types, so you can get a little bit closer with certain surface types. I think that, but here you can see you're losing the mound, right? Completely, like there's no more mound there. So you have to add in a lot of detail to make it work. And we recommend meshes because Revit uses meshes. And ultimately with the tools, you're making all these difficult manipulations using the tools, and the surface, quote unquote surface output, you know, the mesh output at the very end is really not meant to be manipulated. That's the way we see it. We see that the manipulation is all happening within the tool set, right? And then the mesh should be your kind of final output for, you know, plugging into Revit or plugging into a rendering or cutting a section through or whatever the case may be. And you know, if you're not describing the topography with break lines and whatever accurately, then you're not going to get a very smooth mesh. And I think a lot of times people use the surface to make things look smooth, where they haven't really figured things out, right? You can use a surface as an input for the geo set as well, to smooth, to kind of like make things a little bit smoother ultimately. Or to make, if you want to describe things in a really specific way, like if you've made mounds, like I think of like a, you know, a field operations design where you have mounds that are really highly specific. You could model those mounds and use those as inputs for, yeah, you put it on other geo and suddenly it's changing. It's actually acting as an input. And if we previewed the points of that, Ben can like read my mind now. He's just doing it all. Love this.
Oh, I broke it.
Oh, is it breaking? Looks like it's breaking.
May have added that to a.
Is it?
It's not happy, Chris.
Yeah, it's not happy. Maybe split that in half or something along those lines. Did you cap it?
Yeah.
I don't know. Maybe it's the hole that it's freaking out.
It could be the whole, yeah. It looks like it's working.
There we go. Good job. It was the hole. That's odd.
Yeah.
So yeah, so you can see that topography matches that exactly. And if Ben were to manipulate that surface, did you delete it?
Oh, I just previewed it.
If Ben were to manipulate that, you know, you can turn on the control points, or yeah, just move it up and then hit refresh. It's going to follow that surface really closely. Yeah. Cool. So those are a few things. You're able to, like, while I'm on the topic of smoothing, Ben, go over the smooth modifier to show. I think you had used that on one of our.
Yeah, on the first floor.
Yeah. So Ben, if you were to bypass that, just show everyone what it looks like if we bypass that smooth. So I think those points are, that point preview is off.
Yeah.
So this is what it looks like without any smoothing. But when we do the smoothing, it resamples the topography there and creates a whole, you know, it's gonna kind of smooth things out. You can change the parameters of that smoothing component so that you get, you know, more, it's gonna loosen things up if you have wider spacing. You can also put those in series where you're really smoothing something out, and then you're maybe refining the smooth, and adding in, you know, resampling and adding in more detail again. Those are really great, especially if you want to manipulate. We have other mods for sculpting and grading, which I highly recommend looking into. We won't get into those today, but yeah. Does anybody have any, like, is everyone able to kind of manipulate this example? How's that going?
Chris, that was one minor issue I was having. I think the things you're describing make perfect sense. I'm seeing that the sample definition or sample package here wants version 1.06 components for Topo, and I'm just missing a few components to be able to get the full visualization.
Yeah, we were a little aware of that. We were trying to make sure that we had 1.0.5, but we've been testing 1.0.6, so I think maybe Ben just has a few components.
Fair enough.
We can do a quick analysis of that prior to the second. You know, we can make sure that the second examples are all good to go there.
Yeah,
Ben, you may need to sort of remove 1.0.6 completely. Just make sure it's gone.
and then save them.
Yeah.
Resave them as the lower version. Okay, yeah. That for some reason I wasn't having that issue when I was doing it and testing it, but maybe when I jumped back into 6 for another script that we were working on.
Right. Yeah, it's tricky.
Yeah.
It's tricky.
We'll make sure those are all updated too. So even if it's
Yeah.
like for some reason not functioning properly, we'll make sure that we update those so you could use them later too.
In other news, we do have a bunch of really cool new stuff in 1.0.6 that is just, we had kind of hoped to have it for this workshop, but we realized that we wanted to get it all right before we released it rather than sort of rushing it. So
this is one of those examples that Chris was talking about before that has, oh, it's going to be opening a Grasshopper. This is one of those examples where we built something that happens in Paving Kit, and then at the end of it, we're translating some of that geometry into a different place in order to make something happen. So it's like, instead of having sort of the architectural topo example where we have chunks of workflow or chunks of script that are being copied over to create different functions, we have something that's happening, and then at the end, we're changing it or shifting it to a different location so that it can do a specific task for us. So in this example, we have, so in this case, what we're doing is we're taking sort of this base surface, and so this is sort of the byproduct. You're seeing this sort of brick wall that's a singular plane, and I'll show you sort of a 3D version of that here in a minute too. But to go back to sort of the stepping stone of how this is working, we have this sort of general workflow from Paving Kit that's going on here, where we're creating a pattern based on a specific set of dimensions. So I'm using an 8-inch by 4-inch sort of brick size is what we're using. And then we're drawing the pattern out of that to create sort of a pattern on the ground here that represents the paving that will be translated to our wall, if you will. And so we just have this general pattern that's being generated on the ground. And then what we're doing is we're taking that and we're using just some simple embedded components within Grasshopper to map that surface onto a series of other surfaces that we have here, these 2 different ones, and converting those again to a mesh because we love meshes. Meshes are smaller and easier to deal with, especially when you're dealing with, hundreds of these little pieces of geometry. I believe we have, 1,890 mesh bricks here that are being used for the wall. And then we actually have a workflow here for sort of baking those out with their appropriate colors. So if we look at this a little bit closer, I'll go back to the beginning without trying to jump around too much. We're feeding these in directly. So in this case, we just have, our standard inputs here as the parameter components that we're bringing in these different things, the base surface and the different vertical walls that we're using. So we could actually create another vertical wall here if we wanted to, and rotate it a completely different direction, put it over here, and then select these and incorporate them in as well. And then it will add our bricks to that surface as well. And so we can have a series of different surfaces working together. And the example that you saw there, it was a corner of a wall that was linking together. And we were actually trying to generate a pattern that sort of seamlessly transitioned from one to the other. And that's where this idea of the point of beginning comes into play. where we can start to use this point to determine where the pattern is beginning from, so that we can make sure that across two different surfaces that are changing direction, we can continue that pattern across, and we can use these points of beginning to sort of control. And if you start to play around with Paving Kit and sort of test how that point of beginning works, you'll start to see how you can control where the pattern is being generated across to sort of create that seamless transition between the two. But another thing that we have down here is, a simple set of code that will take these surfaces and sort of figure out their angle in space. That way you don't have this circumstance where the pattern is being generated and sort of changed in a way that doesn't match the actual rotation of the surface. And so what you get is an actual brick pattern that matches the surface according to its location in space. It's rotating the pattern itself to match that each surface custom, as opposed to having a single pattern that's just sort of fitting to the surface based on the original translation. So we get the custom angle rotation of the pattern to ensure that we're not, if we rotate this surface, it doesn't cause any issues for us. And you can see that when we rotate it, it will match the rotation up to it, as opposed for each of them. So you can see that when we're looking at this one straight, it's going one direction, but this one is going the opposite direction because we rotated that one around a full amount. So if we rotate it back around this way, you'll see that it kind of matches the same pattern of this rotation. And again, we're using simple color inputs, nothing too fancy. You can add color rules to this. We've used this in a recent project where we applied a specific pattern to a fence that is creating sort of an art piece on the fence that represents an image that we're using. So that's where we come in and use this image color rule, and you can input a surface that has a image applied to it or a picture applied to it, and it will map that color, the color differentiation of that image. It will map using the different colors that we have available and sort of recreate that image in the grid of your pattern. I don't believe that we've done a deep dive for Paving Kit, so some of this stuff, I believe we talked about it a little bit though in the Paving Kit workshop. So if you have access to the videos for those through the pro version of LandKit and the campus website, you can watch some of those and see how those work. But
yeah, that was the intro workshop.
The intro workshop, that's right. We were able to sort of cover a lot of that there.
Cool. Sorry.
No, yeah, but that's sort of simply kind of, again, it feels like a step back because we talked so much about the ArcTopo. It would have been, a little bit more logical to talk about this before the ArcTopo, but in general, it's speaking to this idea of like, how do you use these components, Topo Kit, Plant Kit, Paving Kit, for ways that aren't just maybe what they're intuitively meant to be used for. And again, as Chris mentioned before in the intro of the presentation, this is something that, is destined to be a feature of Paving Kit versus, something that we can just show as a simple script example. We really want this to be something that people can open up Paving Kit and think about it like a pattern, and think about paving as a wall or a facade and as well, which is something that, if you're familiar with Grasshopper, there's a lot of tools out there like maybe Lunchbox or things like that allow you to create patterns on facades. But sort of the idea of creating a three-dimensional brick, for instance, I think that's something that I haven't shown yet here. So we have these types, and we can set this up to be an extrusion, and the extrusion does add quite a bit of processing time, but then we can get an actual brick here that is represented. So for construction documentation, for visual representation, you can align these walls together to get them to actually match the bricks up. I think the way that the pattern is set up now, I might have to flip this around to get it to do that.
It's great for details as well. So if you want to sort of, show that much detail, it's good for a detail. Sort of makes sense. The one thing you can do is that Ben is, he's left out a little step, which is there's a trim paving.
Yeah.
step, which you can drop in right after you add the standard mix. Actually, not there, Ben. It's
back here.
yeah. And then basically you plug in the area, and you can see there that in our flat version it's trimmed. And then you can plug that in, and that's going to translate across all of your, whenever you're mapping those to each one. So the neat thing about a workflow like this is that it's funny because this is sort of a little bit like the agroforestry one, where you're building a module and then you're deploying that module across different surfaces in this case. But yeah, we're hoping that in the very near future, we're actually in the middle of developing this. In the very near future, you can input these 3 surfaces that aren't flat, and you can set those up as your paving areas. And so the 3-dimensional surface can actually become you're not having to make that translation from one to the other. But this is great for the advanced workshop, because it also shows you how if you're like, all right, well, we're going to use this 29 different times, and we're going to have this, design this one panel. This is a great way to show you how that's going to, how you could deploy that across a bunch of different, right now we're only doing 3 different surfaces, but you could do a bunch of different surfaces. And yeah, this tool, talk about that component, Ben.
The rectangle mapping. Yeah. And this is something I was going to say too, is, for those who are, a lot more familiar with Grasshopper and are sort of more familiar with the transform tools, there's a lot of stuff you can do with these to sort of translate objects from one place to another using sort of boundaries, or, for instance, in this case, the rectangle mapping takes, the rectangle of a shape and the rectangle of another shape, and any geometry that's within the boundary of your first rectangle will then translate and morph to the shape of another rectangle, and sort of fit the geometry to that shape. But there's a whole range of tools in these sort of morph components as well. And you'll see I have a few more in here from another plugin that I've used for other projects that will allow you to do things that are not planar. So, if you're a little bit more adept with some of the transform tools of Grasshopper, you could generate a pattern onto a shape like this. And as long as your other surface that you're using generally follows the same surface parameters of your reference surface, you could actually map this pattern and morph it onto something that's a little bit more organic using some of these morph tools. So the rectangle mapping tool here is something that's a very simple version of this translation from one location to another, but there are more complicated ones that are embedded within Grasshopper that allow you to translate them from one size to another size, or from one simple shape to a more complicated shape. And so the basics of how this component works is you take a bunch of geometry, you take a source rectangle that you're mapping from, which is our base rectangle here, and then you're providing it a series of rectangles that it is mapping to. And so you can kind of see that if I enlarge this surface here, it will then increase the size of each of these different hexagons, or the different shapes here, whatever those shapes are. It doesn't have to be these in particular, to match the size, the new size of my surface. And this applies to a lot of the other tools as well if you start to adjust these. And so I'm pretty sure that the rectangle tool doesn't work as well if I start to change this surface a little bit more complex. It doesn't look like it's breaking it, so that's good. So you can see it's creating a little bit more of an organic shape, and it's mapping it onto that as well. A little bit, not so much, because again, the rectangle tool deals with planar rectangles. So it's sort of creating a rectangle that kind of averages the way that surface is being generated. But there are plenty of tools in here that allow you to do something a little bit more complex with the way that you're mapping from one surface to another. So
yeah, it's the simplest one to use, because the other ones require you to have like a domain set up for the the Z direction of the surface, or the W direction. Surfaces are typically described as UV coordinates and then W would be kind of like the offset direction off of the surface. With this, you only need to provide the surfaces. You don't need to provide any of those domains. So this is a great, a great way just to say, go from a flat surface to another flat surface, or flat rectangle really to another flat rectangle. But yeah, it is interesting how you can like scale up the target surface and just suddenly get a whole other scale. So it's it really depends on what your usage is. If you're trying to design something for for visuals or for something else altogether, this is a great way to do that. Cool. Well, we're at 12 o'clock. I think we should take a little break and give our computers and our brains a break. Okay, so we have a few more examples for you guys. There's this generator script, and then we have our agroforestry script. So this one is the one that's like pretty crazy. Like there's a lot of crazy things we're doing, but it would be way crazier if we weren't using LandKit for this. So I'll let Ben kind of do the lightning tour, and then there's a few things we had with the original script that we wanted to just revisit really quickly. But yeah. Ben's done some nice stuff with trees and mounds and things that help.
It's like a more simplified version of what you had before, which I like. Your more like dynamic one is pretty exciting. Yeah, this will like, I guess, provide a nice overview, and then once we jump into that one, it'll be nice to see. So this whole script is sort of born out of this sort of conceptual idea that we have that there's an opportunity to, again, allow the computer to work for us, but in an iterative way, to provide lots of options and examples for what you can do on a site. And so, by outlining a range of different parameters for how the different zones of your site are being generated, you can provide yourself a lot of options to look at and review, sort of in the same way that you might take a piece of paper and pencil and sketch out 10 ideas really quickly, just with lines and directions and things. This is a way of doing that kind of computationally. And, not necessarily saying that this is the final product of your site, not to say that you couldn't set up a script that would do that for you. Let me know if you have trouble hearing too. But this like provides a nice way to sort of say, okay, well, we know we want this many zones, we know we want this types of paths, these types of paving areas, and then just deploy it on the site with sort of some randomness to it that allows it to generate something sort of unknown or unexpected for you right off the bat. And so what you're seeing is one iteration of an example of this that we're talking about, where you see the overall script here, and you can see that we have these different zones that are being generated. So you have an overall site, and from the site, it's feeding a bunch of different geometry to generate paths, to generate your grading for the site, to generate your paving for the site, and to generate your soft areas or your green zones for the site as well. And then we've added a little chunk that will take the green zones or the soft areas and add in locations for trees and create a bunch of variable trees. So you get this sort of central city park type feel in a generative way. And all of these are linked directly to a seed engine here that allows you to filter through the different iterations of this, so that I can just hit this next number and it will reprocess everything with a new seed number and provide you a completely different example. And something that we've done for this that's pretty exciting is you can animate this and have it generate 50 or 100 JPEGs of just all the different iterations of this, and then you can filter through those and see like, okay, this is providing something interesting for your site. But overall, kind of generally how this is working is you're creating a site based on a rectangle, and the cool part about this script is that you can open this script in a blank Rhino file and it will work. All of the geometry that you're using for this script is being generated within Grasshopper. So you don't need any rectangle in here, and you could obviously set it up if you have a specific site, provide a rectangle or a site shape to it to generate. But in this case, what we're doing is we're using just a general rectangle for the site, and we're using a combination of different tools being generated in Topo Kit, such as the Create Areas component, which feeds over to different areas, and Paving Kit, so that we get sort of our paving pattern being mixed in with the whole site. And then we're also using the areas and the topographic tools of Topo Kit to regrade the site using randomized points and paths and things like that, so that we can create these sort of randomized mounds in the green areas of this sort of city park type feel. And something that you'll see in the second sort of iteration of this example, this is actually the second iteration of the example, but the original example is that Chris incorporated topography into the paths as well. So you get sort of a dynamic feel to the way that you're moving through the site, in addition to the sort of mounding and changing of the site in the green areas. So we'll show that pretty quickly too, and have Chris kind of talk about that. But you'll see that throughout this, we have a variety of different clusters that are being used in different ways to sort of feed that random seed generator throughout the site, so that at each moment, when you add a different iteration of it, you're getting a completely random version of the different aspects of the site that are being generated. So the locations of the trees are a random value different from the values that are being generated for the randomness of the points that create the mounds, and the locations of the paths and the widths of the paths too. So you end up with this sort of interesting pattern that's being generated throughout. But again, this speaks to the whole idea of like embedding parameters within. So if, I'll kind of step through it a little bit more too, but for instance, with the tree script, which is really simple and short, I've sort of analyzed the edge of the boundary of the different green areas, so that none of the tree trunks overlap with the paths. Because theoretically, if you generate a random point on a surface, it could be close enough to the edge of the surface that the tree trunk could overlap with the path. So thinking about things like that are incorporated into the generative script allow you to control these parameters to generate something that is actually useful to look at and sort of real world example applicable in some ways, without necessarily saying that this is what the site is going to look like. But this also still organized, but without a whole bunch of clustering of components. You get that sort of general Grasshopper, large script Grasshopper, bigger beyond imagination look to it that you see in a lot of Grasshopper scripting tutorials and videos and examples. But the breakdown of it is once you kind of get into the weeds, it starts to become a little bit more logical about creating a site, creating the boundary of your site that you're working within, this rectangular shape, and using that for generating paths that have random locations along the edges of the site and within the site as well. So in some cases, we have these larger paths that link to the edges of the site that create a polyline in between them, so that you get the outline of your overall path system that links to your outside world. And then in addition to that, you have these smaller paths that allude to some sort of activity within the site that are being generated by connecting to the actual polyline itself as well. And again, I'll try not to get too in the weeds with this, since we want to try and get through this in a timely manner and talk about the other script as well, given the time frame. But the paths come down and feed back into this whole idea of incorporating Topo Kit into the overall idea, and using the areas and the projecting of areas to create the final product of the actual coloration of the paths, instead of creating a Brep, coloring the Brep, previewing the Brep, and having to deal with it in that way. Is we're processing everything and then creating a mesh out of that, and then coloring the mesh, as opposed to dealing with lots of different surfaces in the final processing. And the grading incorporates a lot of concepts related to Topo Kit and Paving Kit too, which allows us to see, different unique tools like the using the smooth topo to get, nice smooth mounds, but also using things like grade topo to create, these nice mounds that are being smoothed through the green areas. But then, you could take the mounding idea a step further and use a random generated collection of, in this case, we're using Paving Kit to generate a grid of points. And those points are being used to create these sort of unique mounds on top of the site itself, so that we get, patterns of mounds and then organic mounds as well. And you can kind of bake that into the whole script itself to create areas with organic nature and areas with logical and structured nature to them, so that you have you can create that sort of dynamic interaction between what we think of as something that's very organized and something that's very naturalized, the Hargraves versus the Central Park, if you will. So then again, like, you come back up here and you see sort of a sorting of, you have your paths and you have your site-based area, and you're saying, well, everything that's not included in the path becomes another area, and these areas become, paved surfaces. So in this case, we're sorting through these areas and we're making sort of a random decision about what becomes a paved area versus what becomes a green area or a soft area. And Chris, you might be able to speak more to the nature of how that decision making was baked into the script itself and constructed.
Yeah, it's not super sophisticated. The stuff we're doing with this is really, it's really like a demonstration piece, and trying to sort of say, hey, like, you could generate all of these different things sort of using random inputs, but any one of the random inputs could be more intentional, right? Could be more of like a manual input or a more conditional input. If I'm looking at, so where are you in the script? You've got, can you zoom in on those scripts, those sort areas? Maybe open up that Python. Looks like we've got a bunch of different Python happening here. Yeah, just expand that. So looks like we are getting the area, and then we're figuring out which things are green versus paved, and we're just doing it with just the mesh area, which we could hypothetically do with a bunch of grasshopper, but it was just like for whatever reason, I decided to do it with Python. And you can, some of those components, actually, Ben, it's a little faster if you don't say okay and you just close it.
Yeah, I was going to exit out so that doesn't reprocess.
So the get area surface is interesting. It kind of speaks to a question you had earlier, option, which was, oh, can you access this stuff? Well, if you look, the input X, that's an area, right? So it's not like we've created plan areas, and we're pulling the original geometry out of it. And I think this is why I made the other script as well, so that we can actually calculate things about the area in the midst of processing everything. So because otherwise we'd have to go back, right, and sort of figure out what that original geometry was. So it's a way of pulling out the attribute of the original geometry after we've sorted them out, right, to get those surfaces. Yeah,
because these plan areas are the plan areas from Topo Kit. So like custom package of geometry.
Yeah, exactly. So like if Ben were to, if you click and create a new line and type X dot, this shows us all the attributes of an area. So there's all these different, there's actual variables, there's, attributes. There's even some functions in there that you can run. So it's an interesting, way of kind of like digging in and sort of doing more with the script, with the fact that it's not just a, piece of geometry, right? That, which is typically what you're looking at with Grasshopper. This allows you to kind of dig in and sort of pull out those different attributes of those kind of data objects, like the wall, the topo, the plant, the paving area, the environment. Like there's all these things you can, all these attributes to them that you can access. Yeah. So.
Yeah, I think something that gets talked about in a lot of the actual LandKit workshops. It's something that that what you are talking about right there speaks to too, is that the package geometry before it's previewed is something that's easier to process and easier to manipulate before previewing itself. And oftentimes in Grasshopper components, processing and previewing the geometry, the action happens to the geometry and then outputs the geometry itself simultaneously. And so you're dealing with the actual physical geometry every time that you change it in each step of the process. But if you're changing a lot of the geometry before it actually generates the geometry itself, then your processing is a lot faster. And that's sort of the benefit of the way that Chris has sort of coded and structured Topo Kit and all of these different kits themselves too, to make things run a lot faster.
Topo Kit in particular is, it's like you're kind of preparing, like when you're manipulating the topography, like you're adding mods and things, it's really just adding all of this, a big recipe of what it's going to do, right? When you go to draw it, right? So it allows you to hypothetically turn off that one component and still do all this different stuff, and then sort of activate that draw topo component when you're ready.
Yeah, I just wanted to ask about that because I saw like these scripts, they're running super fast, based on my experience. If you want to work on something like that, it shouldn't happen like, with one click. And I think that's one of the best feature of the Topo Kit, the LandKit.
Yeah. And, there's plenty of instances where there's a lot of data that has to be processed and it's going to take time, when you have a very large site,
of course,
thousands of plants and you're, millions of pavers or whatever the case may be. It's the nice thing is that it's parametric. You can always figure out how it works at a really small scale and then plug in the larger shapes. And with the pretty high degree of confidence that it's going to work at the larger scale as well. And that's something that we really like to do is to kind of think in terms of building recipes and prototypes at these smaller scales. And then, whenever it's time to work on a big project, we can build that smaller thing and then we can deploy it and, really invest the processing time we need to otherwise you're manually drawing something, right? So it's still way faster than you'd ever, that it would ever be like just doing something manually. But from a computational side, it's going to really be a factor of how much geometry and how powerful your computer is, et cetera, et cetera. Yeah. And how cleverly you've set up your script, I think sometimes in certain cases.
And then sort of continuing a little bit, since I think we probably need to shift over to the agroforestry here in just like a minute or two, but there was something that you talked about too, Chris, in the architectural topo, how, you can kind of like take different pieces of geometry and incorporate them into multiple aspects of the script so that as one thing's adjusting, it's adjusting the other as well. And I think that this is a pretty good example of that, where you're creating your paving patterns for your paving areas, but then you're using the green surfaces from the soft areas as an attractor to adjust the gradient of the coloring of the pavers so that no matter where your green areas land in your generated script, it's going to use those locations to create a gradient of light to dark moving away from those green areas. So within the script, you're generating something, generating another thing, and then using one thing to affect the result of that piece. So here you're getting the green areas, yeah. And that's being used as an attractor for the color rule of the pavers that are being fed in, so that the lighter color pavers are closer to the green areas, as you can see, and it's creating a subtle gradient of darker colors moving away from those green areas. So it's kind of like a nice, like, subtle feedback loop baked into the whole process itself.
Yeah, if you preview that, it should show that it's only using the one. Oh, no,
yeah,
this.
it's just using this one up here.
It's only grabbing one, but if you were to bypass and plug that in, it would
there you go.
It would suddenly, and then you've got to change the distance maybe to like 20 or something, and you'll see that gradient much more clearly. It should kind of, yeah, there you go, fading away from those green areas. And if you wanted to flip it, you could just reverse that. You know, just reverse the order of your gradient, basically. Yeah. So there's a lot of like little things you can just do in the script, you know, and just to adjust how the overall thing is working. And you know, we've made certain decisions here that in some cases are really very arbitrary. Yeah, I think maybe Ben, just open that other script really fast, just because I would just love to point something out to yeah. So the neat thing about this particular one is that you can see how the grading kind of moves across the path in a really great sort of logical way. It's not doing it for these little paths, unfortunately. But if you just kind of hit F5 or something, regenerate, what we're actually doing here is we're using the path line as a way of grading within Topo Kit, right? So we're using that as a markup or an attractor in some sense. I kind of honestly forget how I set that up, but I think you know, this one's a little different, where we have kind of, this is actually a depressed area that's a little bit more random, and you get kind of this you know, marshier kind of condition, and then you have this kind of more architectural grid of mounds. But the neat thing about this one is that there's an overall grading that's happening, and so if you see these mounds, you can see that the grading ties in there, right? Like it's actually it's not just like superficially added in a sense, like it's really integrated, and you could cut through at an even higher resolution of contours. And that's another neat thing about these tools, is like you're really building with the 3D mesh, and so the contours can act as a really more of a byproduct than an input, right, to the process. And so if you figured it all out, and you can do your 1 foot grading, but then you can kind of maybe do micro grading as well. Like you can spit out a bunch of contours and maybe you're making a few tiny refinements to your spots or something to get but yeah, that's more of just like a general Topo Kit thing. But yeah, there are weird things here, like where that sort of does something a little wacky there, but yeah.
Also, you know, as sort of like a general idea generator, you know, you have something that's starting to generate the, and refine the script itself to generate something more specific based on, you know, what you're trying to achieve.
Yeah. All right. Do you want to do that agroforestry one while we?
Yeah, we'll jump over to the agroforestry. Okay. So this is a fun one. That looks like I dropped something. Okay, so I'm just going to sort of zoom out and show this is a pretty organized. It's sprawling, but that's just so that we have enough space to sort of see everything that's going on. And I organized it a little bit so you see the different zones that are happening. But this whole script is being generated. The script sort of builds around Plant Kit. The whole goal and the idea that this sprout like kind of came from and was birthed from was the idea that Plant Kit uses this sort of rule-based placement, but the rules-based placement doesn't necessarily have to be plants. And so we thought about it in the realm of like, can you decide, where the best parks are in a city using Plant Kit by making your plant a park that has a certain set of parameters that you're trying to locate on your city, your cityscape. And so this was sort of the example of saying, well, like, could you do the same for a farm? Could you say, I have these sort of modules of examples of what, an orchard would be, or like an agroforested plot would be. And can we make sort of a prototypical example of what one of those sort of sections of plots would be, and then find the best locations across the huge acreage of farmland to place these plots on, and then actually generate the plants on top of those plots themselves too, so that you're doing sort of a two-step process of, let's identify the best locations to put an orchard and a wetland and an agroforestry plot and our urban environment, or like our barnyards and things like that. And then let's organize those sort of plots across the site based on the analysis of the site itself. And then let's actually generate the plants that are supposed to go on those plots in the plots themselves. So in general, it starts the way that most Plant Kit systems start, by creating an environment. And you have an environment that's based off of your boundary of your environment, which is just a simple rectangle, and then your topography here. And we're taking that environment, and if you follow it over, we're feeding it over into these different agroforestry areas. But we also have an analysis layer being added to here. So we have this general environment that's being created over our whole site. And what we're doing is we're adding in these layers of environmental analysis that analyze the soil moisture and the soil type. So if we go into Plan V really quick, and we look at this, we might have to turn on wireframe. You can see these sort of pieces of geometry here. And if I expand these, you can see that we've sort of generalized these just as an example. We just have sort of 4 examples. We have soil types fertile and infertile, and then we have soil moistures as wet and dry. And so in this case, we have a zone that's specified as a soil type that is considered fertile, and then we have, or infertile, and then a soil type is structured as fertile. And you can already see, just based on where these boundaries are, that there are certain types of plots of plants that are being placed within these zones. But in addition to that, we're adding a second layer of analysis that's saying, where are our wet zones and where are our dry zones? And again, it's also speaking to certain types of geometry. So perhaps our dry and full zones encompass a certain type of plant or plot structure in these, and it can be said of these, but of the other different combinations that you're dealing with. So we're embedding within our Plant Kit environment these different types of layers, the 4 different types of layers. But ultimately, what we need to do is we need to identify on our site where are the best locations for these different types of plots of land. And so what we've done is we've created plants. So we have a create plant node here that is divided them out into wetland, urban, silvopasture, and agroforestry. We've given them each a color. Go ahead, Chris. Were you going to say something?
Yeah, maybe just zoom in a little bit more, Ben.
Okay.
So people can.
So we have our species of plants that we've named these sort of general plots, and we've assigned to them a certain set of values based on what they prefer to be in. So for instance, in the agroforestry plot, we've said that their soil type, their soil moisture should be wet, and their soil type should be infertile. For the silvopasture, we've said soil moisture should be dry and soil type should be infertile. And so then what you have is you have these generalized plots that are being placed across your entire topography that are saying, look for an area that's this, and place a node there that represents agroforestry or wetlands. And that's what these cell locations represent. You'll see that we have, if I zoom in here and I look at this, you'll see we have 4 different branches, and each of them have a number of different plant locations that represent where each of those different types of those typologies are being placed. And you can see that we can put that across an entire grid, and that grid itself right there is actually being decided by our environmental analysis cell size up here. So if I was to change the cell size, it would get more detailed or more broad or more generalized. So we have our cells, so we have our cells organized across our entire site that says we know the locations where like agroforestry plots would prefer to be. And what we're doing that is we're feeding that up into our cell location vectors to determine where on our site. So these will be the vectors that sort of guide our sort of plant plots to be being placed on our site. And then over here, we're creating a series of 4 scripts that represent the different types of plot types. So we have our agroforestry area. So we're creating a prototypical agroforested area here. And I think that we can actually preview that. Or no, I took that part of the script out, but I can show that. I can put that in and show it. But we have a plant list that we've generated, a second plant list. So we have created plant lists, and this is providing us a different types of trees and plants that we're using to represent the different types of plots. And then we're selecting these different plants that we've created. So we've provided a couple different parameters here, different radii, heights, and things like that to sort of guide like the structure of the different plots that we're creating. And so currently each of these plots are only creating one of them. We're just creating one plot at the origin that will eventually be moved to the appropriate location. And so what we're doing is we're saying, I want you to select these certain types of plants to be categorized in the agroforestry area. And then it's filling moving around a lot, it's filling this sort of general curve here. So there's a little plot right here that we're using as our area template. I believe it's right here. We have our template being generated right here. So this is just a single planting area that's being encompassed by this rectangle. And inside of this rectangle, which is again using the same parameter of size of plot that is being used as the cell size for the sort of generalized plot location identifier. And we're creating plant areas to generate a series of plants within that plot for each of the different prototypical areas that we're creating, the different plot areas that we're creating. And then what we're doing is we're pulling out the locations of those different plants, and we're sorting them and organizing them based on the locations using these vectors. So once we get to here, we have our plants placed on our individual plots. So a plot here, the agroforested plot, has 136 plants placed on it, that little rectangle that I showed you. And we're identifying the locations, and we're replacing the plant areas based on the overall topo, so that we have the overall topo. It's moving all of those plant spheres to the appropriate locations relative to the plot across the entire topo, and then making sure that they're projected to the appropriate elevation on that topo. I tried a couple different ways of doing this, Chris, and fixing it to see if we could integrate those 2 concepts into one. And it might be kind of like a fun follow-up to do, to sort of test it out and see if there's a section of this code that we can actually reduce down to 1 instead of having 2 parts to it. And we can talk about that later if you want. But so then the result that you have at the very end is you have all of your plants in these different plots, and you can see that the plots are very standardized in these rectangles, placed in their appropriate zones as individual plant spheres at elevation. And so then what you can do is you can do large scale farm and site planning using this sort of 2-tiered step that still allows you to visualize the final result with having a lot more grid organization over a larger scale. And even if you don't want to actually place your specific plants on the site, you could use a general shape or node that just places on the site itself for sort of a large scale planning without having to do the specifics of the plants themselves. So the first step to this process, I think, kind of speaks to something that is the alternate use to plant kit, where we're saying we're not trying to identify a specific plant location, but we're trying to identify a general location for a type of usage across the site. Whereby maybe in this case, if you're using it in an urban setting, you might say, where is the best place to build out a suburban environment versus have wetlands versus have skyscrapers? And then it might come down to, you know, where's the best soil for putting in foundations for skyscrapers versus foundations for houses versus low points for wetlands. And you can start to define plants that are actually representations of something else other than a plant that organizes the site.
Yeah, it's because it's sort of at a small scale, but also at a large scale, it's about suitability, right? So we're trying to sort of find the most suitable location for a given module. And then within that module, what's the right location for the plant? And so there's a little bit, I mean, it's when you're dealing with that small of an area, that the actual plant, you know, location within the area is a little bit more about like, what are the logistics of harvesting, and at least in this example with agroforestry and so, or what, you know, how are rows coordinated and things like that? Does something want to be random versus in a row? You know, this Ben made a good point that this is like, if you really go down and look at this from like a, you know, ground level view, you know, all of the plants are at elevation, like every single plant based on, based on the exact location of the terrain at that location. But this could be treated in a much more abstract way. You know, it doesn't necessarily need to go to this degree. You could essentially, have your, design your little module as a key and show what that module is supposed to look like, and then just have a colored square which describes where your zone would be, or taking it maybe one step further, actually deploying the modules and having them be in a 2D sort of mode, just to get a diagram or a plan of the thing. It's funny because I feel like we have to remind people of that there's all these levels of detail that they could do, that they don't necessarily have to take it to this full degree. But the really neat thing here is you could then suddenly start to do sunshade analysis for other stuff around here, right? So like that, there are some really nice aspects of this. We're working on tools for water and things like that we think would be great for not only placing some of these modules and figuring out where the wettest soil would be, so you're not drawing manual boundaries, or you're not necessarily having to pull GIS data. But we also think that once you have all these things placed, there's other really interesting things you could do. Like if you're modeling water flow, you could maybe begin to examine where certain plants are, and maybe where nitrogen is moving around, or like because of the water flow and things like that. So that there's some interesting kind of some potential for expanding this idea.
Even in that example too. Sorry, just before a question, I guess we have like 10 or 15 minutes here left, but thinking about it, I mean, you could apply the concept in the application to like urban planning or urban design seems fairly logical, in that you're simply changing the parameters of what what the plant or the actual module or the thing that you're trying to identify, the locations that you're trying to spread out, are being sort of filtered through in maybe a CSV or in the Grasshopper script like we're doing here. We could have just as easily created a CSV file that outlines what the different modules are and then feed the CSV in here, and then it just reads a CSV of the different types of information that we're working with. And then you can add and subtract from that CSV to change how the script is being expressed or showing. But, you know, like the idea of once you start to incorporate water flow and, you know, talking about things like nitrogen, identifying, you know, where is the water flow going from your agricultural fields into a river or a water source, and using that as ways to identify places to put rows of trees or forested, you know, like a forested buffer to prevent the nitrogen from actually making it to the water stream, things like that, that I think are relevant conversations that conservationists are having today about protecting our waterways from agricultural runoff. So there's like big idea of whether you're talking about a very large scale city environment or just your farm, your specific farm, and trying to protect your waterways on your farm, that this could easily be applied to make your life a little bit easier than trying to sort of figure it out using contours and GIS data and stuff too.
Yeah. Or your productive landscape, which is like a nice kind of, you know, idea that's sort of emerged in the field, you know, sort of just thinking about landscapes that aren't necessarily for looks, you know, and for people, but they're, you know, the habitation of people, but they're maybe also for producing, you know, producing food, producing, you know, or you know, also performative landscapes. Obviously, where, you know, this is another thing we're hoping to help solve with some of these tools and allow people to have the ability to sort of model the system, not maybe completely necessarily, but to kind of get a much better sense of what their design decisions are doing, and not necessarily at just this agroforestry scale. As Ben said, like we could be thinking of typologies at a really big scale, or even thinking about site layout of things that aren't plants. Like, where do certain activities want to go, or where does certain, you know, furnishings want to go, you know, things like that really could start to, you know, you plug this together with a generative, you know, the generative, the site generator that we had in the last example. I think you could have some pretty insane stuff going on. Any other questions? I know we're making this a little shorter than we had planned, partly because Afshin is leaving, but also because our crowd has dwindled a little bit. I think the real trick here is to dig into the script and to see how things are set up. One thing I did want to mention is I think Ben is using the actual cell location, or our team used the actual cell location of the environment. You could also pick your own pattern. Like you could use Paving Kit to do, you know, some other pattern that's maybe an offset grid, like a sort of like a running bond, or, you know, it's like Ben said, he likes to think of it as pattern kit. So there's other patterns that we could follow to do this. We could, you know, build hexagonal, you know, we could make this a sci-fi movie if we wanted to, you know, use hexagons. Oh, you're muted.
Or not patterned at all, even, and use plant kit to remove the pattern from the whole conversation and identify locations around the site that are perfect outside of a pattern, as close as possible outside of a pattern, and then generate sort of plots that sort of connect together this randomized location to create your plots to place something in, or to identify the locations that you're working for. So it doesn't have to be within a pattern. Plant kit works outside of a pattern generally, and then you can add a pattern into it. So that's something to keep in mind too. Like, you generate a random you're just using PlantKit to identify the best location across the whole site based on your cell size that you're working with, and whether or not you want to create an actual shape that you're working with for your plot to put something inside of it or not. You could work with that. You could use Voronoi or something like that to make it a little bit more fluid in sort of its touching where it sort of meets each other, or you could just use the actual point location itself to create just a general plot to place things on, or just use that analysis in its own right. Just say, this is the central point that is the best location for this type of thing. So let's build out from here to the next spot and think about it that way. So
yeah, there might be a tool set that's helping you to get a general sense of things, and then you go in and draw manual stuff, right? Like we think of it, it's sometimes really great at giving you a final product, especially with, say, like Topo Kit, but in Paving Kit. But when it comes to certain Topo Kit stuff and certain generative stuff and Plant Kit, it's really, it becomes a very exploratory tool, where you can get a sense of the organism of the site and how it is functioning, or how it wants to function based on the parameters you're beginning to give it, or the rules you're defining for the site. And I know that's zooming way back out again to really generalist stuff, but
oh, it's fun in here.
Uh-oh, something blew up.
No, I was gonna pull something in while you were talking that could be kind of fun to look at for this example, using the some of the PlantKit tools that color the mesh based on a gradient from point to point on the cell based on the analysis that you've done. So then you could generate sort of like a gradient map on your site that shows like this color, this central color and its deepest color represents the best location, and it gradients away to the best location for something else. So then you could manually draw lines over top of that represent your sort of best locations for your sites. And that's sort of another way of like combining the manual analog with the computational to sort of make your life easier.
Yeah.
So I have a few comments. Most of them are about to appreciate what you're doing, guys, here. And I'm kind of familiar with Grasshopper and coding board, so I know how much work has been invested to develop these tools. And I think one of the most interesting features of your tool is that I've talked to Chris about this before, that especially for students, for the ones who are really early in their career, to get exposed and to have the ability to work with, computational design tools. And then at the same time, you provide this opportunity, for the users to go advanced, to dig in, deeper. They can, as you're showing right now, if you want to add something custom, it's totally open. It's up to you if you want to take it to the next level. And I think that's one of the most important tools that are missing in the field of landscape architecture. And I really appreciate what you're doing, guys. And I'm pretty sure that you keep developing, and it's unlimited, right? So you have, as you said, these are just like for demonstration. And as you're talking, I can't stop thinking about, other options, like urban planning, waterfront, and it has so many applications. And I know it's hard to explain every single of them, but the fact that the computational design method, how it works, and how it can inform, it's even beyond that design iteration, as you were talking, in terms of site analysis. And not necessarily you have to use it for generate design, but for analysis. And like as a designer, if you're more comfortable with what I call like the traditional method, at least you can take advantage of the analysis that you can do in these computational design tools. So yeah, I wish I could stay more, but yeah, thank you so much for your presentation. And I'll have to open the files, just like play around with them a little bit more to see what exactly is happening behind the scenes. That was I'm more interested. And yeah, hopefully we'll be in touch.
Absolutely. Yeah. Let us know if
Yeah.
you get lost. We're here.
All right. Thank you very much.
Thank you.
Yeah. Thank you.
Bye now.
Bye.